Hello, good day to each and everyone. Welcome to the second part of our video discussion series on the deformation of the Earth's crust. The first video, we talked about how deformation of crust happens because the weight of the Earth's crust continuously changes over time. We also talked about the different isostatic adjustments that are happening on the Earth's crust and how it creates and produces stress which are experienced by the rocks, which at the same time causes also strain, which results also to the different features like folds and the creation of faults. So for today's video, we will continue where we stopped and focus on the formation of the mountains on the Earth's crust. So sit back, relax, and just enjoy this video discussion with a moment of science with Mr. Rabino. A mountain is one of the most spectacular feature of the Earth's crust. If we refer to the deformation processes that happen, we could somewhat say that mountain formation is one of the most extreme type of crust deformation. Like for example, Mount Everest, which is of course the result of what we call as the continental collision, which in which the elevation of the mountain itself, if I'm going to look at some of the information found on the internet, it's around 8 kilometers above sea level, which is of course what makes it as the Earth's highest mountain. And the forces inside the Earth causes Mount Everest to grow taller every year. So technically, our Mount Everest is still growing. Okay? So the Mount St. Helens, like in the US, a volcanic mountain, captured the world's attention in 1980 when its explosive eruption devastated the surrounding area. And many mountains, like the famous eruption of Mount Pinatubo, which of course killed many lives and destroyed many properties. So we could somewhat say that the mountain range system and its formation is one of the most extreme types of the deformation of crust. So we are going to focus our attention on this discussion. So allow me to focus on what I have prepared for you for this discussion. So when we speak of mountain formation, we refer to it as the process of orogenesis. Oro from the Greek word meaning mountain and genesis meaning to come to being or the beginning. This is what we call as the process of forming mountains and mountain ranges. Okay? So usually there are different types of mountains and mountain ranges, and these mountains and mountain ranges are also associated with the interactions that are happening in the plate boundaries. So first, let's talk about folded mountains. These are formed because of plate convergence and typically due to the continental collision, which is the force of compression between two continental plates, which folds the crust, developing into a mountain range. We know for the fact that a continental crust is a thick crust, but at the same time, a very buoyant crust because of its relative lesser density than the oceanic crust. So imagine if two continental crusts will collide with each other, of course, subduction will still take place. But because of this inherent buoyant property, the crust experiences what we call as the uplifting, or shall we say, the upwarping effect, which causes the formation of some of the tallest mountain ranges that we can see in our planet. And of course, a good example of these folded mountains is the Mount Everest from the Himalayas, and of course the Andes, somewhere in the southern portion of the America. So These are some of the examples of the folded mountains. So another type of mountain is what you call as the volcanic mountain range. So from the word itself, these are constructed from volcanic materials. Specifically, they are constructed from accumulated lava flows, pyroclastic, and other igneous rocks that piled up over time because, of course, of the different volcanic activities and eruptions occurring in a nearby volcano. Now, for example, in a typical subduction zone that occurs between a continental and oceanic crust, if the oceanic crust subducts over the overlying continental crust, then we can expect that a trench system is formed. And parallel to a trench system is, of course, there exists what we call as the volcanic arc, which is, of course, a chain of volcano as a result of the subduction of an oceanic crust underneath the overlying continental crust. So let's also focus on another type of convergence, which is the oceanic convergence. And as oceanic convergence occurs, the two oceanic crusts, when they collide, the denser oceanic crust usually subducts. And as you can see, it forms a deep sea trench. But at the same time, because of the formation of the deep sea trench, then we can also observe what we call as the underwater sea volcano. And the eruption of this underwater sea volcano will also cause some of these volcanic materials to pile up on the surface, which will, over some period of many years, will form what we call as the volcanic island arc. We will tackle later what's the main difference between volcanic arcs and volcanic island arcs. Okay? So, here, for volcanic arcs, these are curved chain of volcanoes. We have to remember this. In the overriding tectonic plate of a subduction zone. Take note of this, ha? And form as the result of rising magma by the melting of the downgoing plate. And usually they are curved because of the curvature of our planet. Or if we would like to understand this in a very simple manner, these are curved chain or belt of volcanoes. Take note, belt of volcanoes form along subduction zone where one plate is forced beneath the other. Okay, and usually it is in the interface between a continental crust and a oceanic crust, where oceanic crust usually subducts under the continental crust. Now, a good example of this is, of course, the Pacific Ring of Fire. Why is the Pacific Ring of Fire a good example? Because the Pacific Ring of Fire consists of numerous chains and arcs. Like, for example, in the Cascade Range in the northwest of North America, and then we also have the Andes Mountains in South America. We also have Japan, Philippines, and Indonesia, which are, of course, chain of volcanic arcs. So that's why the Pacific Ring of Fire is a very good example of a place where these volcanic arcs are usually found. And no wonder why these areas are very active tectonically speaking. Okay? Then let's talk about island arcs. Typically, they are located in the middle of an ocean basin. Okay? Far from continental land masses. They are often found in the open ocean surrounded by water. Ooh, when you speak of uh, often found by ocean, then surrounded by water, we can actually think of many examples of it. And they are usually associated with convergent plate boundaries. But in this case, they form when one oceanic plate is subducting beneath another oceanic or continental plate. Okay? So, what's the main difference now between these two? Now, in the essence, um, volcanic arc can include islands or mainland volcanoes or belt of volcanoes. But the island arc is usually associated with chain of volcanic islands only. Okay? So for volcanic arcs, they can include the island itself or the mainland volcano. But for island arcs, they are called island arcs because they only consist of volcanic islands that are formed because of the tectonic activity caused by the either volcanic eruption, so on and so forth. Okay? So, what are some good examples of volcanic island arcs? We have here, of course, Indonesia, which is a very famous country in terms of its activity, volcanic activity. In fact, in Indonesia, we can find several many famous volcanoes like Mount Krakatoa, Mount Tambora, and to name a few. Then we also have the Philippines, which is of course um, one of the regions found in the Pacific Ring of Fire, and we are also home of some of the most active volcanoes like the Mount Mayon, Mount Taal, Mount Pinatubo, to name a few. Last one that I could think of is Japan. Well, Japan is actually an island arc, and it's very obvious because usually an island arc is found on the convergence of two um, plates. In particular, let me tell you just a brief story of how these plates or how these island arcs are formed. So, for example, for Japan, we know that Japan is located near the Pacific plate. So, technically, what happened was the subduction of the Pacific plate and Eurasian plate, the subduction of Pacific plate over the Eurasian plate caused the formation of Japan. Now, for Philippines, we know that we have our own Philippine plate. The Philippine plate subducts underneath the Eurasian plate because Eurasian plate is a continental crust. And then we also have Indonesia, which is of course home of the Indo-Australian plate, which of course involves very complex process because number one, the Indo-Australian plate subducts underneath the Eurasian plate at the same time the Pacific plate. So no wonder Indonesia is very home of some of the most active volcanic um, activities. So those are some examples of volcanic island arcs. Now, you might be wondering, in our previous discussion, we talked about that divergence of plates can also lead to volcanic activities, like, for example, the formation of Iceland. We know for the fact that the divergence of plates between the North American and the Eurasian plate form the island of Iceland, and that is formed because of the volcanic activities resulting to the divergence of plates. We might be wondering, uh, is divergence of plate also can also form um, volcanic island arcs or volcanic arcs? Well, the answer for that is although divergent boundaries can exhibit volcanic activity that may result the formation of island arcs or the islands itself. The mechanism is relatively different from the subduction in the convergent boundaries. Like, let me give you an example. In the East African, in the African Rift, um, where the African plate is somewhat splitting into two because it's a rift valley. Take note of that. It's the splitting of two continental plates. It results in the formation of volcanic mountains and arcs like the East African Rift Valley, at the same time the formation of Red Sea. Although these are volcanic arcs and island arcs features, the process is somewhat relatively different from what we are referring to the volcanic island arcs and volcanic arcs discussed and that are formed through the subduction of plates. So somewhat they are different. Okay, so the answer for that is that divergence of plates are not usually associated with these volcanic arcs and volcanic island arcs. Okay, so I hope that you get this distinction out from the two. So allow me to proceed right now. So, oops, I just emphasized here the example. Now, there is also a particular region in the Earth's mantle or asthenosphere wherein we call it as a hotspot. A volcanic hotspot is an area in the mantle from which heat rises as a thermal plume from deep within the Earth. And the high heat and lower pressure at the base of this lithosphere facilitates the melting of the rock. And this melt, which we refer to as magma, rises through the cracks and erupts to form volcanoes. And as the tectonic plate moves over the stationary hotspot, the volcanoes are rafted away and new ones form in their place. And this results in the chain of volcanoes such as the Hawaiian Islands. So, how does a hotspot occur? Um, I'm going to show you an animation in the second part or in the third part of our video on this one. Okay, so this is an example of a hotspot volcano, like the Hawaiian Islands and their principal volcanoes. You can see the entire island of Hawaii is actually are volcanic islands. So sorry for the wrong term. It's not a volcanic mountain range, although they are volcanic mountains, but call them as volcanic arcs or volcanic island arcs. Okay, so those are some of the examples that we can think of. Then, of course, trenches are some of the features that are formed due to the result of the subduction. And we know for the fact that the deepest trench system that is found in our planet is the Marianas Trench in the Pacific Ocean, which is, of course, the deepest known trench so far in our planet. So, we already discussed this one, so we will have to proceed to the next one. Okay, there. Of course, the mid-ocean ridge, which is formed by the movement of tectonic plates on the Earth's surface. It is a divergent plate boundary where two tectonic plates move away from each other. And as the plates separate, magma from the Earth's mantle rises to fill the gap, creating a new oceanic crust. And this process is actually known as the seafloor spreading mechanism. Okay? So, an example is, of course, the mid-Atlantic ridge. Then, we also have some types of mountains which we call as the erosion form mountain range. But this type of mountain range is not actually associated with the movement of plates, but they are just formed because of rock erosion and weathering. And a good example for this is the Appalachian Plateau in the eastern United States. We also have what we call as the Dome Mountain Range. Now, for the Dome Mountain Range, it results from the upwarping of tectonic plates and are not accompanied by the collision of plate boundaries. So, meaning to say, it doesn't result from the movement of the plate, but instead because of the upwarping effect caused by the movement of the magma and the pressure that it exerts towards the Earth's crust. So that's how a dome mountain is formed. So a good example of this mountain is, of course, the Black Hills in South Dakota, where we can see the faces of the four famous presidents of the United States. So from left, I cannot actually memorize the names. Yeah, I only know George Washington. Then I can see also is I think that's Theodore Roosevelt on the third, and the fourth is Abraham Lincoln. I forgot the second one. Maybe that's Andrew Jackson. I Please correct me. I am not familiar with the U.S. presidents. Okay, so another type is what we call as the fault block mountain range. The fault block mountain range is a type of mountain that is formed because of the tensional forces experienced by the rock due to the normal fault, which could uplift large block of crust. And the displacement of crust produces cracks and parallel mountain ranges. Like this is how a typical fault block happens. So number one is just a normal crust, and when this number two happens where tensional forces are applied on this crust, the tension that is experienced causes stretching and cracking on the surface of the rocks. And as it happens, the middle portion of the crust, which we call as the graben, falls under the influence of gravity. And as a result, the horst becomes elevated, forming a fault block mountain. A good example for this is the Sierra Nevada in California, and the Marinduque Mountains, of course, in our very own Philippines. So that actually ends our discussion for this video. So in summary, mountain ranges are formed because of the deformation of the crust that is happening on the Earth's surface. Although most of these mountains are formed due to the movement or interaction of the different crust that is, of course, found on the interaction of the different plate boundaries, there are also types of mountains that are not associated with these plate movements. And these deformation of crust, although it might be somewhat very rough at the same time, very cruel, the process itself is very brutal, but the resulting effect gives the earth its wonderful feature, which makes our planet a very beautiful place to live in. And that ends our discussion for today's video. And I hope that you have learned something out from the discussion that we had for this video. So once again, this has been your instructor and your lecturer, Mr. Marvin Earl Orabino, saying that I hope you have learned something out from our topic for today. See you around when we see each other. Goodbye, everyone.